Good evening once again, students. In the previous class, we had discussed about few architectures. I mean to say, as of now, we had discussed only one architecture. Okay, that is what's it? Just a moment. Yeah, workload distribution architecture. I thought it was dynamic scalability. Fine. So going forward, we will discuss about the other fundamental architectures. Okay, and in which resource pooling architecture plays a crucial role in it. See, as the name itself indicates here, we'll be planning to pool up the resources, pool up the IT resources. You definitely know the cloud will be provided with enormous amount of IT resources, and these enormous amount of IT resources will have to cater its customers. Okay, so in doing so, definitely you can think about pooling the resources. You can definitely think the pooling of the resources. Why? Because resource optimization has to be done at every point of time, whether it can be any type of resource. Okay, it has to be optimized for its usage, and pooling is one such mechanism where you can see the resources are optimized to the fullest extent. So we will see what exactly happens in the pooling of the resources. See, you will come across many resources, as I told. I don't go with the variation of the resources at this point of time, but I will just name the resources and say, like, how we will be pulling up with our friends to commute to the college, isn't it? In the similar sense, okay, in the similar sense, the resources in the cloud environment will have to be pooled across the clients. Okay, here either at some point of time, even the resources from multiple cloud providers also have to be pulled up. But usually, most of the time, the resources will be pulled across the clients, across the customers only. That is the prioritized thing. Okay, so that's the importance of resource pooling. Definitely, we need to cut out the price. We need to see that optimal usage of the resources are happening. That to the fullest extent, these resources are expected to consume, isn't it? And coming on to the allocation architectures, okay, allocation architectures, definitely these resources are pooled in certain logic. These resources are pooled in certain logic. Okay, we will discuss what those logics are, and we will also discuss what kind of resources can be considered for the pooling. Okay, so among the resources considered or else can be considered in the cloud architectures are basically, you can think about the physical server pools, and I wish each and everyone to constantly go through the images first. Okay, and you learn that these images are entire the textbook. If anywhere certain terminology is being used, then its image will be used over. In the sense, at any point of time, if you are talking about physical server pool, then automatically you can come across this image in our entire textbook, or else in our entire architecture series. Okay, even in the workload distribution, you could have seen that physical server is in this color and the virtual server is in this color. So I want you people to very carefully observe on these images which are being constantly used, and hence you have to very constantly understand what exactly this image will be meant by. Got it? Okay, so to start with, the first, physical servers are considered for the pooling. Okay, how do you define the physical server? How do you define the physical server? Or else what type of things, what type of entities you will be calling it as a physical server? Usually these physical servers are composed of servers. It can be any type of server, but with a similar functionality. It can be of any server, but with the type of similar functionality. And these servers have to be available in the same network. In the sense, In the trust boundary, they are supposed to be present. Okay, so any server that is of same functionality and within the same network, then you call them as physical servers ready for the pool. Okay, you can club them to call one such pool. Okay, similarly, you can also come across virtual server pools. Virtual server pools, that means on the physical servers, definitely we'll be creating many virtual servers, but at the same time, okay, you can also have virtual server pools, but here in the form of templates. The virtual servers will be available, or else the virtual servers pooling will be done. Okay, it is something like as the example says, any cloud consumer can set up a pool of mid-tier Windows servers with 4 GB of RAM, or lower tier of Ubuntu servers with 2 GB of RAM. That means in a single shot, okay, in a single shot, he says that he wanted certain operating systems server with dedicated and with the pre-identified size of the RAM. Okay, so likewise, he can come up, he can pull up the resources. Here, in this example, I also wanted to tell something like what is mid-tier and what is low-tier. Low-tier is, in the racks of arrangement, okay, you can see that, okay, the first tier that communicates will be the lower tier, next is the middle tier, and the final one is the higher tier, or the topmost tier, what will be calling, okay. So in the virtual environment, when you are catering the virtual servers, okay, you will be coming across this tired architecture of servers. Okay, of course we will not be discussing much of the tired architecture as part of the curriculum, but we will just understand that virtual servers will be created and virtual servers will have to be maintained. But definitely, if I'm not wrong, you could have come across these tired kind of things in cloud computing lab as well. Okay, when you had access to the virtual managers. What I mean to say is VirtualBox or virtual machine, that is VMware manager or else VMware workstations or else ESX servers. Okay, you can come across these kind of you know the tiered architecture where virtual servers are involved in it in the form of templates. Okay, so virtual servers will be considered for pooling, and definitely it will be in the form of templates. Now, apart from the virtual servers, what can be the thing? The next possible thing is the storage points, isn't it? Storage pools. Okay, so you can consider multiple what is a multiple vendor storage pools as also. In the storage pool, you can think about storage pool from a single vendor or multiple vendor. But the thing is, whenever you are creating the pool, okay, you have to consider whether this particular storage point should be partially filled or fully filled or entirely empty kind of thing. Okay, so even the status of these pools will be directed according to this factor also. That means whether the storage area or else whether the content of that particular storage point, okay, has to be empty, or it is partially filled, or it has to be entirely fully filled up. Okay, so that's about the storage pools. Okay, moving on to the next resource, you will be coming across network pools. This is something like, in other words, sometimes it is called as interconnect pools also, but these are all these network pools are entirely pre-configured connectivity in network connectivity devices. Entirely they are pre-configured, and you can come across these usually in the firewall devices. Okay, in the firewall devices. Okay, it will be in the firewall. Say, for example, you will be what to say, you'll be allowing certain type of networks. Okay, and you can also restrict upon certain type of networks, isn't it? Okay, so that sort of pooling will be usually done for the cloud entity. Okay, but also it does not limit to that pooling to the firewall level, but it also been observed at the physical level also, physical level as well. In a sense, say if you are hosting one machine, one on one single server, if you are hosting on 4 machines, okay, 4 virtual machines, out of which two machines are connected with NAT bridge, NAT internet connection, and the other two are connected with bridged internet connection. Okay, so which means that it is how the IP has to be shared. That is it. Okay, so in bridge, automatically you will get a new IP, but in NAT you will be sharing as a subsystems IP. That is what. Okay, I don't want to go deeper about those IP sharing and how this NAT connectivity works and how this bridge connectivity works. We are, we don't have interest in touching how those things will be work. Okay, so but do understand that there are kind of connectivities that is happening for the virtual machine with the physical machine that is on the hosted machine. Okay, so these connectivities also can be considered in terms of the pools. That means all the machines with a NAT connectivity can be pulled up into one thing, and these can be assigned with certain network privileges. Similarly, all the machines with bridged network can be pulled up into one thing, and even they can share about their IPs as well. Okay, at an enterprise level, okay, these play a crucial role. These play a crucial role. Why? Because most of the times, if you wanted to go with the static IP, you are supposed to pay the provider, isn't it? For the DHCP, that is for the dynamic IP, no need for you to pay. But if you're opting for the static IP, then definitely you're supposed to pay. At that point of time, these things actually matters. At that point of time, these things actually matters, isn't it? Okay, so these network pools, what they can be doing is, they can play a crucial role in load balancing, especially, and aggregating other resources. Aggregating other resources. Why? Because these resources major activity itself is to get the interconnectivity, isn't it? Right. So while doing so, they play a crucial role in aggregating the devices, in the sense in arranging the devices based upon certain order. That's how it is. Say, for example, if a subsystem has been created in the sense subnet IPs has been alerted, then I can come up with a list of the machines with certain IP series, isn't it? So according to this, you can understand that the network pooling can control upon the devices aggregation and also the balancing part. Okay, that's about the network pools. So the next resource that can be shared is physical RAM, pools of physical RAM. Like many examples I would have given till now, like how we will be adding and removing the physical RAMs, isn't it? Okay, so you can come across with pooling of such RAM resources as well. Okay, and other one is CPU pools. Remember, the image for the RAM and the image for CPU pool, more or less they appear to be one and the same, but there is a difference. And I want you people to observe this. Why? Because when you are merely interpreting an architecture without its indexing, okay, it is very much confucius most of the time that CPUs will be what to say, uh, uh, falsely identified as an RAM. Usually that happens. Okay, so don't misinterpret it, or else don't get in a wrong direction. Okay, so that's about the variation between the memory pool image and the CPU pool image. What happens with the CPU servers as well? Okay, so the central processing units. Okay, the components of central processing units can also be pulled up. To allocate the resource, see what exactly is happening is, whatever resources I am having, I am trying to accommodate. Whatever resources I am having, I am trying to accommodate. If you remember one good old movie like Anukokunda Guruzu, there in that movie you can see a person, okay, the hero or some other lead role in the movie, he would carry almost 20 people in one ambassador car, and he wanted to be fully utilized to the fullest extent on the way he is going. Okay, so he can barge upon to any person, and he can what to say, he can offer to any lowest extent so that his occupancy will be more and so that's his kind of model. So in the similar sense here in the cloud provider as well, so he need to think about at any point of time he don't wish to keep a resource idle. Why? Because if it is idle, it is not fetching him money. If it is idle, if it is not fetching his money, it is as simple as that. In the similar way, okay, even the transport organizations usually run their buses also. They spend lakhs of rupees on in getting the instruments, that is nothing but the buses. And do you think they operate the buses overnight and they keep it silent or else idle on the daytime? Usually, no. We feel so. They are idle, but they are used for many other purposes. If it is in government uh, transportation, they run buses for the shorter distance. Majorly, their idea is to increase upon the occupancy rate. That is it. Okay, so that's how when you have certain resources, you try to get maximum out of it. Okay, why? Because these are not simple resources, and these are not what to say cheaper in getting the price for them. No, the cloud provider has to invest more money, okay, lots of money into in acquiring them or else in purchasing them. So obviously, we try to get fullest out of it, isn't it? That is what we'll be calling it as return on investment, ROI. When you talk to some business investors, okay, so they're thinking, or else their thought process is entirely in terms of ROI. You are investing 10 rupees here, okay, fine. In what sense you are getting your 10 rupees back, and how does it help you? That is what all the business investors or else financial personalities will be thinking about. In the similar sense, you can think about the resources that is available in the cloud, and they are meant for fullest utilization, and no room is left empty in capturing the benefit of such resources. Okay, and also what can happen is when you try to create certain resources, okay, usually you will come up with certain combination of the pools also. You will be coming up with certain combination of pools. It is something like, when you try to get the subscription for your DTH, okay, of course you will be opting the language channel what you wanted, but apart from that you will also be given with some other channels. It doesn't matter whether you like it or not, but it is a kind of pool that has been created for the subscription, okay. Of course, nowadays government denies that, and government purely tells that, okay, only the interested channels are to be paid, collected fees from the viewers, and only those channels has to be telecasted for them. That's a different story, but in such similar sense, okay, how the DTH subscription will be coming along with, okay. Similarly, when a cloud provider is approached for certain resources, then he can be planning up with certain CPU resources, that is CPU pools, I can say, and memory pools, storage pools, and the network pools, and if necessary, server pools also. Okay, so it depends upon the kind of package what he would like to offer, and it is also, I mean, even for certain restaurants will also be offering these kind of packages, like family pack, uh, uh, what to say, with the two biryanis and one curd rice, one cool drink, blah blah blah, kind of, such kind of packages. Okay, all these are all perfect example for pools. All these are all perfect example for pools. Okay, and what happens in how these resources pooling can be accommodated, how these resources pooling can be accommodated is, resource pooling can be accommodated in two sense. One is sibling resource pools, and another one is nested resource pools. Okay, so usually there is a huge complex architecture will be formed up when you are talking about the resource pooling architectures. Okay, usually you'll be ending up with a very complex architecture. Why? Because the hierarchy that is being formed, okay, creates that sort of complexity, at every point of time, his resources will be not free, and at the same time, all the customers have to be satisfied. All the customers have to be definitely satisfied. It is something like, all the persons have to be seated in the car, and at the same time, they are supposed to go to their respective locations in that movie. That's what it is, isn't it? Right? So it's a very complex thing. Okay, so to reduce, I don't say exactly reduce, to properly understand that complex architecture, okay, the resource pooling can be done in two ways. One is in sibling resource pools, and another one is nested resource pools. What exactly happens in sibling resource pools is, okay, so first, basically one resource pool will be formed up, okay, where you can come across certain servers, certain memory, certain CPU and network as well, okay. Out of these pool, okay, out of these, the first occurred pool, okay, sub pools might be formed. Sub pools might be formed. So, for example, here in the figure on the slide, you can see that, okay, first pool A is created. First pool A is created. That is, this pool A consists of 4 virtual server pool, 4 CPU pool, 4 memory pool, and 3 network pools. For this pool A, okay, out of these resources, siblings would be formed. So, similarly, pool B is formed from pool A. So how this pool B is formed? Pool B has again virtual server pool, but only 2 resources of the virtual server pool. Similarly, all the 4 CPU resources will be needed from the pool, and entirely memory pools also will be needed. That means 4 memory pool and 4 CPU pool, but virtual server pool is only 2 has been consumed. On the other hand, from the same pool A, you can also come up with another sibling where uh, 4 CPU pools are created, 4 memory pools are created, and also 3 network pools are created. Similarly, I can come up with another pool like pool D, and this time I can come up with the 3 virtual server pools, 2 CPU pools, 4 memory pools, and 1 network pool. I can come up with any such type of thing. But all those siblings should be in line with the parent pool. It should be in line with the parent pool. That means whatever the pool of resources that has been accumulated in the parent pool, among those resources only, these sibling pools are to be created. Okay, it doesn't mind, okay, it doesn't mind how these resources will be using. Why? Because parallelly they might be using, and simultaneously also they might be using. Let's not worry how the resolution or else how the problems will be avoided when these pools are being consumed in the cloud. Those are not in our curriculum as on today, right? Now coming on to the next one is the nested pools. In the nested pool, what will happen is, again, here you will be coming across parent pool with more number of resources. Not exactly how many number of resources are present in the pool. You can either go with all the resources, or you can go with half of the resources. That means, say for example, the total of the siblings, or else the total of the sub pools that are being formed, okay, should be equivalent to the resources pool that is present in the parent. Okay. See, in the previous example, I will once again repeat. Here there are okay, I will take the CPU pool as an example. Here you could see 4 CPU pools. In both the siblings, you could come across CPU, same quantity CPU pools. That means 4 CPU pools in pool B, 4 CPU pools in pool C as well. You got it, okay? Similarly, memory pools also of same size. But for pool B, you could see that the virtual servers are less. Okay, that's not a problem. But what happens here is, in the nested pooling model, if 3 resources are given to one particular pool, that is pool A1, next in pool A2, you cannot go with more than 3 resources. More than 3. Why? Because the total of all the resources in all the subpools should finally be equal to the resources present in the parent pool. You got it? Okay. Similarly, you could see that there are something like 1, 2, 3, 4, 5, 6, 7, 8, 9 CPU pools, where out of these 9, 5 are uh, pulled up with A1, and another 4 are pulled up with A2. Similarly, there are 7 memory pools where you could see 4 are pulled up with A1 and only 3 are pulled up with A2. Why? Because there is no possibility for A2 to scale more memory pool over here if it is a nested model. But if it is simply sibling model, it can go and have all the 7 also here. That's the greatest difference. That's the greatest difference. Okay. That means in the sibling pool, you will be giving entire thing. Okay. You will be giving entire thing, whatever you have. Okay. But that is not the case with the nested pool. Only it should be taking, or else the pools can be formed according to the possibility of the resources, according to the possibility of the free resources for that matter. Okay. That's about the two types of pooling that can happen. Okay. Before going to the mechanisms, I just once again repeat what and all the things that can be considered in the resource pooling architecture. See, in the resource pooling architecture, we have to pull up the cloud resources across the customers. And what type of resources can be pulled up? You can pull physical servers, you can pull virtual servers, you can pull storage points, you can pull up network resources, you can network resources, yes, and you can pull physical RAM and CPU cycles. Okay, so when you club these kind of resources, you call them as one such single dedicated pool, isn't it, right? Usually the pool architecture is very complex enough because of the resources that are being hierarchically arranged while usage. So to avoid such type of complexity, there has to be clarity upon how the resources can be pooled. So pooling can be happening in two ways. One is sibling resource pooling, and another one is nested resource pooling. See, in sibling resource pooling, the siblings can be having all or else minimal to the maximum availability of the resources in the parent. But in the nested pools, that is not the case. Siblings can have a total of those resources that are equivalent to the resources present in the parent pools only. They cannot go beyond. They cannot go beyond out of it. Okay, that's the difference. Okay, now to have these things into existence, definitely the kind of mechanisms that can be needing here is you can come across audit monitor. As I told, definitely you need to understand how the cloud will be cloud resources will be using, and how the what to say monitor the kind of activities that is happening on the cloud entirely. Especially when you are using the sibling pools. Okay, this audit monitor will have to be in key place. Okay, why? Because say for example, if the same amount of resource is being given, that is, it is something like I have only one mobile phone, and I have to cater my two sons classes with that mobile phone. And see, that's the kind of resource pooling what I should be doing. And if they have a class at the same time, then I can give to only one of my son, not both of them, isn't it? I cannot break the phone, or else I cannot share that, isn't it, right? So that is the thing. So I need to properly monitor. That means I will be checking upon when the classes are, and at what time the class will be starting, and at what time the class will be ending. So I will be very cautiously planning the usage of that particular resource. Okay, so that's the usage of audit monitor, especially when resource pooling is being happened. Okay, coming on to the cloud usage monitor, as I told, cloud is pay per use, and definitely you need to think about how this particular cloud is being used, and how many resources are being allocated, and what is the charge or as a bill that has to be charged for the customer according to the usage, and hence you definitely need this. Okay, and coming on to the hypervisor, definitely you have to create the resources, isn't it, right? You have to go upon virtualization, or else you have to come up with the physical resources as well, and hence at any point of time to maintain or else to recreate the resources. Okay, definitely you have to make use of the hypervisor. And obviously the logical network perimeter, which I was stressing in the previous architecture as well. To cater all these things, we have to know the boundary of the trust boundary. Okay, so that is the boundary of the cloud's network. Okay, so without which it is not possible for you to allocate the resources. And the pay per use monitor, as I told, the cloud usage is entirely based upon the paper model, and few things can be offered as a complement, or few things have to be definitely should be on payment basis. That is something like you can use the SMS free, though you have 100 SMSs, but at the same time you will be ending up to pay for the calls you will be making in the mobile service network provider. In the similar sense, okay, you have to pay per the use, and hence there should be proper monitoring mechanism. And definitely the next mechanism is the most important one for this architecture, that is remote administration system. Why? Because these resources will be catered to the different customers, and the proper orchestration of these resources should be happening, and for which administrative privileges are highly expected, and those things can be done only by the resource administrators only. And definitely, as I told, all the time you cannot expect the resource administrator to be staying with the cloud. He can be outside the cloud, or else he can be part of the cloud, isn't it? He can be with the client, or he can be with the cloud provider, as I told. Okay? So for this, definitely remote administration module should be enabled, and that mechanism should be up and running. Okay, and resource management system, that's what the administrator does, isn't it? So he need to take care of such management. Okay, so you can say that resource management system is a part of remote administration system as well. And finally, the resource replication, as I told, in the within that logical network perimeter, if at all, if you want to create more number of resources, okay, if you want to create more number of pools, okay, so you have to definitely have a resource replication mechanism. Okay, so with this, we are done with this resource pooling architecture, and